Yeah, thanks everyone for coming. My name is Aaron He. I work on the Android platform team at Tinder.
Yeah, and my name is Siggi Jonsson, and I'm also from the platform team at Tinder.
Today we're going to talk about modularization. You know, in the community in the recent years, modularization has been a big topic. We're just going to tell our own stories from a single monolith repo and monolith module, how we get to 300 modules today. First of all, we're probably going to cover some of our engineering stats to give us a little bit of background. And then we're also going to share a few mistakes we have made and how we fix them. So yeah, I'll just give a couple of highlights of our Tinder engine engineering. We currently have 31 engine engineers, and we have 23 openings. So you know what that means. We have hundreds of commits every week. The code base is about 2 million lines of code. 85% of column, 2 million lines of code does not include JSON, XML files. So you can see that it's a huge code base. And currently we have 300 modules. And our clean build time is an hour, which I lied. Actually, just 6 minutes without build cache. To provide more context, I want to talk about our architecture. We have an architecture called Atom. It stands for Asynchronous Transactional Oriented Manager, which I also lied, because we actually don't have a cute acronym for our architecture, but this is how it looks like. You can see the timestamp on it says 2016, so this is where we were at 2016. It's your view getting events, talk to a view model, and the view model does all the business logic, does all the view logic, and then talks to the use case. Use case is gonna handle all your business logic, and then it could, like in today, most of the features some of the features are powered by state machine, which drives the business logic. But also when the use case needs to grab some data, we talk to a repository, which will be implemented in a data repository. It may go to the data store to grab the data from the data store, or it may go to Wire to talk to our Tinder backend APIs. So this is how it looks like. So you may get a hint from the color boxes I'm using. So you can see there's a very clear separation of concerns. We separate by different layers. There's presentation, domain, data, and API. And in 2016, we have this big Tinder module, Tinder application module, basically hooks up everything. I think that it was a time when Android Gradle plugin just hit 1.0 and Gradle 2.0 hit Gradle was 2.0, and I think everything just compiles very fast in a single one module. At my last job, actually, we did have a multi-module setup, but because everything compiles so fast in single one module, so we actually convert everything into one module. But then because we want to enforce this kind of boundaries, so we basically package by layers. So we have presentation package, domain package, and so on and so forth. All the classes are, some of the classes are package private by default, so you don't have access. But still, because everything lives in one single monolith module, so there's still no kind of nice boundaries we have where if we have a rule, let's say the view model does not talk to Tinder API directly, there's still no enforcement on that. So we thought about a little bit. Early in 2017, we basically pull out those dependencies, pull out this package, and then we pull out into different modules where we have presentation, domain, and data module. So this is how the dependency graph is going to look like. We have this presentation module, and then we also have domain module. And then presentation just depends on domain. So this is very obvious. And then on the other hand, we have data module, which handles all the data data store persistence layer. And then we have the API module, which goes to the Wire, talk to our backend API, and then data just depends on API module. The domain module itself doesn't. It does not complete because we need the data module to provide this kind of we have this reverse have this inverse dependencies where the data module provides the implementation for the data module. Let's say a data repository will be lives in the data module, and then the repository interface actually lives in the domain module. To hook up with everything, we have Tinder application module. Basically, depends on everyone, and then provides our dependency, so it can complete the the entire dependency graph for the domain module and for the presentation module. So we quickly just when we were working on those modules, especially like, for example, for data module, we compile it so fast. We can write unit tests so quickly. One of the things we do is we have a lot of database migration. So we can have in our data module, we can just have our the migration tests, and then we can run super fast. We can run update from schema from V2 all the way to 16.
All right. So this is all like good and well. We've like modularized the app, but it's still only by layer. And we wanted to kind of take this further and modularize by feature, because hopefully most people realize now the kind of importance of that as the team grows. And also, like while like Aaron was saying, the data module had tests that were running fast, you could iterate quickly on those. You're still left, like when you're working on your UI, your activities, your fragments, whatever, you're still like, you need to compile the entire app, and it kind of becomes tedious, and your tests run a bit slower because it's all part of this giant setup. So we thought about how we could fix that. And the first module we used to kind of start addressing this issue was a feature we called super likable. So yeah, let's take a look at how we achieved that. So if we kind of consider this like the base setup, we have like the domain layer there to the side, but all the features are now like neatly packaged in the Tinder application module. And we want to like extend that without adding more to that one. So to achieve that, we just create an Android library, like the actual Gradle library, and we developed the feature there. But quickly we find out that, well, we need some resources from the app, and we need to be able to share those. And because the dependency is from the application to your library, then you can't access those. Yeah, as shown by the red line there. So fixing that is quite simple. You just add, you can either move them into your module, but we realized obviously immediately that that wouldn't scale very well. So we created this base module. And like, yeah, extracted like what we thought would be like, what would make sense as the common resources. And we extracted those into a base module. And now the dependency graph makes sense. And as we add more features this way, they can also depend on base and share all the nice things. The same applies for like some of our common dependencies. They're currently only exist in the base module. Your feature module can't access those, so we need to do something around that. So in some cases, we just also moved them to base, and everything was nice. So yeah, let's take a look at existing features. Like taking a look at the graph we had there before, we have these mysterious feature A and feature B. And we're going to take a look at how we can extract them from the base module using this pattern. And let's start by like looking at the dependencies. So feature A and B, they both depend on the same set of resources. They have some shared dependencies within the app as well. And despite our best intentions, a lot of the time they would just have direct dependencies on each other as well. So breaking this apart was tricky at times. So yeah, if you try to pull them out directly, all those things will break, as you can see by the red arrows there. So we need to do something about that. And so we apply the same process again. We look at the resources and we say like, well, like what belongs only to A, we can extract that out. And what are like more common resources that we want to move to base. So everything makes sense again. So we move those features, those resources into our feature module, the common ones into base, and now we need to do something about our common dependencies. And this is where like just some good old like inversion comes into place. So we need to invert those dependencies. So we define our contracts on those pictures, like as interfaces, and then we provide implementations for those contracts in our base module. And now it's just a little bit of rinse and repeat. So we do this again for other features, and this kind of evolves over time. And I would, by the way, recommend doing this like incrementally and over time. You're not gonna be able to achieve this in a single day, and all of a sudden everything is split out. So yeah, we repeat the same process for feature B. Extract the resources, move some things to base, and what we end up with is something like that looks a bit like this. We have kind of defined clear contracts for each feature, and those implementations turn out to be pretty thin and live in the application module that glues everything together. Yeah, before going further, let's discuss this base module again. It seems like an obvious choice. It sounds like it's a strategy a lot of people have employed to kind of go into the modularization, and it kind of worked out all right to begin with. But over time, as we started doing this more and more, it kind of just got bloated. It kept growing, kept growing. We kept adding things to it, like, well, I need these two things. Like, I need these things in two places. It goes into base. Everything goes into base. So we wanted to address that. And like, well, when I say like everything goes in there, I'm talking like strings, layouts, custom views, OK HTTP interceptors, logging stuff. So it's kind of, there was like no structure to it, or like it was getting out of control. So what we did to kind of counter that is that we started to break our base module into what we just refer to as our common modules. So we'll have things like common resources, common ReactiveX, common logger, common app lifecycle, and so on. And there are actually quite a lot of those, and we try to keep every one of those common modules as small as possible, limited dependencies as much as we can, and then when we need to like use them in our feature modules, we get to just pick and choose only what we want. So our graph, instead of having this giant base module, every feature module can just kind of pick and choose just what you need. And yeah, sorry about that. So, and just to kind of circle back to what Aaron was talking about at the beginning, so we've like broken down our features into feature modules, but we also like we want to keep the layer separation. So we have, for each feature that we pull out into modules, we like have actually 3 or more Gradle modules where we have each part of the puzzle. So the benefits of going through this process, besides like cleaning up your code, then there's like improved build speeds, and it helps like with team ownership and isolation, all those nice things. But one thing we were still kind of missing was like the rapid feedback. And if you compare this exercise with like microservices, and like if you're deploying for a backend, you end up with everything being independently deployable. So you have these small units, and you don't you can just like look at them as one whole. But we're doing Android apps, so at the end of the day, we need to package everything into one APK, get them on a device. And if you're a developer and you're developing your layouts, your UI, you're doing animations and those types of things, then like you want that process and that feedback loop to be as short as possible. So we started to look into kind of how we can shorten that and how we can make use of these modules to kind of help us with that as well. And our solution to that, I mean, we only had one app, so we decided we'll just create another app, and we'll call it the demo app. So we created the demo app. It's just empty, it does nothing, but you can configure it for each feature module and pull in things that you're working on. You don't need to see anything else. Yeah, you don't need to see anything else, and what this means is like your dependency tree is really small, and you can just get very rapid feedback. And this is really useful if you're like, tweaking animations and moving things around, and you don't want to wait a few minutes or something between changing values or paddings and stuff. So we did this for this feature, like we were developing a new photo grid where you can upload photos. So we did that initially, then another team came in and added where you could upload like small videos to the same thing. And we still use this demo app to kind of iterate very quickly on this view. Another project where we made heavy use of this was when we were overhauling our authentication flow. In that case, we set up the project in a way that we could pick and choose in our demo app where to run the runout flow with the actual backend implementation that's hitting the backend and authenticating, or we could provide it with mock dependencies where we stepped out things. And this was really handy when testing edge cases and error scenarios and those types of things. So yeah, the setup looks something like that. Instead of having your Tinder module depend on everything and everything that's in that tree as well, we just create this separate app that we never intend of shipping, but it's very useful for development that just depends on one module and its dependencies, and you get much faster iterations. The way we did this is we kind of configured what everything you need to bootstrap your demo app, in the main variant or the main source folder for the demo app, and then we made use of build variants. So when a team came in and wanted to utilize the structure, they don't have to spin up their own app and do something on the side. They can just kind of inject neatly into this and do whatever they want with the feature they're doing and make use of this. And yeah, we used flavors or build variants in Gradle to achieve this. And every feature that wanted to make use of demo, they define their own flavor, which means they get to define their own dependencies. And there's very minimal setup, and yeah, this has worked very nicely for us. We have, I think, 42 different variants of the demo app where just different feature teams have decided that they want to make use of this. So we think it's been beneficial. And one just trick if you decide to do something like this is disable your release variant, because you probably don't need it, and it just makes Gradle do twice the work. So all right, back to Aaron.
So now we have demo app, so we can. So first of all, we already have modules, right? So we can have modules. So when you write view model tests, when you write repository tests, it will be very fast. Now we also have demo modules, so you can verify your UI tweaks very quickly. You can always constantly making UI tweaks very, very fast. But we not gonna ship demo app to the app. If we release a new photo grid, we can't tell the users, hey, please download this standalone app. Let's just see all your photo grids over in the app. We still want to have everything shipped in this one single APK called Tinder. So how are we gonna just join all the features modules into Tinder? So I think Dagger, we use dependency injection very heavily in the app. I think Dagger provides very nice modularity and safety. Especially I want to highlight on safety is with our code base, with 2 million lines of code, with constant features being developed, we don't necessarily want to add new dependencies and find out there's cyclic dependencies when you actually when you're so deep down run the app at the runtime, and then so deep down in the feature, and then find, oh shit, there is a there's a cyclic dependencies. We want to have this compilation safety, very early on to have shortened that feedback loop. But for your feature component, what's the job for the feature module? The job is just to extend your app component. Your app component provides your very base minimum dependency you will need for everyone. But to extend app component, what's the technique under the hood? I think it's the very obvious choice is thinking about a subcomponent. But we've done some researches, and then we have some thoughts. But let's first take a step back and to see how the setup is going to look like. Let's say we have this onboarding flow where it's just for like new user signing up the app. We want the user to give us informations like your name, your birthday, all sorts kind of information. And then we have this onboarding module where it encapsulates everything you need in just for this feature. And then we have this onboarding component to provide your dependencies for this app, for this module. And then in your app component, you can just hook up with you could just extend the onboarding component, and then just adding your onboarding module as well. And then in your feature module, back to your feature module, you would have app component provider to get your app component, and then hook up with your onboarding module. Except you cannot do that because it's in your feature module. You don't necessarily have this is kind of a cycle dependency again, where your feature module can depend on the application module. Someone could argue you could just pull out this app component provider or whatever into a base module or common dependency module. But still, that dependency module has to know about all your feature modules, which still defeats the purpose of, it still would create a cyclic dependencies. So fortunately, Dagger have another way of doing this. It's called component dependency. So in your feature component, you would have a dependency on you would declare this parent component, which this little hack at Dagger where we create a interface which there's no any dependency injection annotations. It just declare all your dependencies like your repository, your logger, your analytics tracker, for example. And then in your feature component, you just declare that those parent dependencies is your component dependencies. And then still, you would have your feature module as well to be included in the graph. And then in your feature component, and then you also define an interface called feature component provider, which provides you the feature component. This will be very handy later, because in your application, you can actually. And so in your application, in the app component, you can just implement the feature component parent, which let Dagger to generate all the code for your component, like the builder and whatnot. Then in your application, you can just get the component builder plus the parent, which is the application component, going to provide all your dependencies for your parent, and then you can build that component. And then in your feature module, we just cast this context to a feature component provider, which is the application context, and then you can provide the feature component. So yeah, so now we have the prescription.
Yeah. So let's now we have a way to modularize, and we have a way to do it effectively. So what we found out happened in our code base was we very rapidly increased the number of modules, and we quickly went from a few modules to tens, and then we're up to, like we said earlier, up to 300 modules now. But this happens very rapidly. It's kind of hard to have oversight completely over everything and know what's going on. So we're we get into situations where did that make sense? And we're did we over-modularize in some cases? So this is an example for our settings page, which is split across at least 6 modules. And we're I don't know, it's granular, but maybe we went too far. Maybe this could or should just be one module. So it's still something we're experimenting with and learning about. And then just the giant question is what is a feature module? What needs to be how do you justify that you need to go and extract something out? What makes it deserve to go in its own Gradle module, and you all this overhead? You probably don't want to do that for a single class, but I don't know, maybe you do, and we have some examples of that as well. Then another question that comes up is how self-contained should it be? We talked about the dependency injection, but maybe in some cases you want your feature to be more self-contained, and it knows how to fulfill all its dependencies, so you can just invoke it and don't have to configure anything, don't have to do any DI or anything in your application. And we kind of did one experiment where we looked at how self-contained can we make our module. And We did that with the SMS auth flow we were looking at earlier, and our idea was we just want to have this one entry point, and you can just invoke it, and like we'll hide the rest of everything from you. We'll do take care of setting up your dependencies, and we're like from the user of that, what we wanted to call an SDK, we didn't have to know anything. And yeah, we started out doing that in demo, as we saw earlier, and we wanted still to be able to provide fake implementations of a repository, so we could debug effectively. That kind of makes it quite fuzzy if that's still self-contained, if you can kind of inject something into it. But you can like configure it maybe. Maybe we can look at it that way. But anyways, we wanted this integration to just look something like that. You add your dependency on this SDK, and then in your activity you just launch that flow. Fully self-contained. You don't need to do anything with it. And then this would start the activity for result, then you could handle the result again. And again, like very minimal integration, and like everything is taken care of by your SMS auth. Then the integration looks like that. When we added the app, we have our we can start this from our login module or some existing places like in our app. And yeah, and this kind of worked out nice as well. There are some benefits of doing that. Like you get compiler avoidance because you're not everything is internal essentially to your activity. No, sorry, to your module, except yeah, everything is internal except only a few methods that you choose to expose, and there's no way you can. So you don't need to recompile your app if something changes in library, is what I'm trying to say. So you get some benefits with that. But like I was saying, it's still it's self-contained to agree. I think at the end of the day, you need to have some glue in your application. You want to share your OK CDP instance or those types of things. So we're still on the fence about how far do we take this, right? And so yeah, over to you.
Yep. So yeah, we sometimes the feature modules can be very self-contained, where the feature modules can complete the graph by themselves. But sometimes, most of the times, we cannot. Those feature modules can just complete their dependency graph, which we don't. So and then there's also a need of sharing dependency across modules, where it was previously we gave a really bad example of how we have overdone the settings module. We have settings, analytics settings, discovery settings, account settings, but there's a need to actually share dependency between those. So we think the correct way to do this is still leverage the application component to share dependencies across multiple features. Where even though in your demo app you can still have those stubbed out with a fake implementation, but when you actually merge into the Tinder application module, we just leverage Tinder to share those dependency between modules. Another interesting thing we found is when context change, implementation details changes too. What does that mean? Let's take a look at one of the features. So let's say Tinder application module depends on feature A. Feature A has the very nice UI domain data, and the UI depends on this common view, and then the UI depends on this logger implementation. But when we are trying to add the second app called Tinder Lite, we took a step back, look at the logger implementation. We don't necessarily want to, because constraints is different, your context has changed. Your constraints is very, very different now. Maybe Tinder admin app, we could send all your logging, but depends on we can send logging information, we can send to the server, we can send debug information to the server. But for Tinder Lite, we don't necessarily want to do that. We just only send we just only want to send the crashes, right? So that's kind of provides a, but now your Tinder Lite still depends on feature A, which inherently has all the, it would inherently would have all the considerations was only available for was only applicable for Tinder app. So what we do, we extract out the logger implementation into a logger interface. This is where all your feature module is going to depend on. And then, based on your context, we would have a Tinder logger implementation, which the Tinder depends on, and we would also have a light logger, which the Tinder light depends on, and then the application just hookups everything because application knows the context. Application knows this is a Tinder light or this is for a different app. So the application can pick and choose which implementation for the logger and then hook up with to be put in the dependency graph. The same case is, we use logger as a very simple example, but same case for a retrofit instance. Everyone, all the feature modules want to talk to the wire, to our backend APIs. But in Tinder Lite, it could be a very, very different setup for the network stack. Maybe we don't want to have like 10 meg or 200 meg of cache. Maybe we want to have, for instance, we also maybe the cache size may be different. Maybe like for loading your images and everything. So that's what we end up. We just feel like when your context change, your implementation detail will change as well. So in your feature module, you can't really be that kind of a self-contained. We still have your application to hook up with with everything. So next step, we are still, we can finish that. Okay. So next steps, we're still a long way to go as well because our Tinder main app still has is probably have the biggest dependencies in the app as well. So we still have a lot of modularization work to do. And thanks everyone for coming. And of course we're hiring. And then if you have any questions, I know this is the last talk of the conference, so but we will be here for a little while. So if you want to have questions, you can just come find us. You can always, Twitter is nowadays the trend, so we are on Twitter as well. You can just add us and ask us questions as well. So thank you all for coming.
Thanks.